So we started section 10.2 last time, and we were taking a look at different displays of graphs and data. So we had left off looking at one called a histogram. Do you remember that one? It looked like bars that went up and down. Let's find it in here. This one right here is a histogram. One of the features of a histogram that's about to change in the next one is that in the histogram, the bars touch. And the reason they touch is because typically speaking, the type of data that we're looking at is on a continuum, right? So here we were talking about the numerical grades, and the numerical grades are on a continuum. In theory, you could get something that's a decimal point or a lot of decimal points of a letter, of a 92 or something like that or whatever. And so it's on a continuum, so a histogram kind of makes sense. Our next one is actually called a bar graph. And a bar graph looks really similar to a histogram, but it has spaces between the bars to depict categorical data. So the bars don't touch because the categories are somehow separated. So the example we're going to do is not what I'm about to describe, but let's say, for instance, you were doing something that was male versus female, or freshman, sophomore, junior, senior. Those are categories of information. They're not on a continuum. So a bar graph would make more sense than a histogram, and we'd have spaces between the bars. The one we're going to look at is the same data set, but we're going to look at it in terms of the letter grade instead of the numerical grade, okay? Which means we're back into categories, because an A is a category of grades. It's not a continuum of grades, A to B. So we're going to look at the same data set that we had before. I'm going to take our grouped frequency that we'd had before, because that's the one we're using here. And I'm going to put it over here for us. So this is our data in kind of a concise form. And it's nice to see it in this form as well, because we've organized it in such a way on purpose that these categories over on the left, the grade categories, correspond to letter grades, right? So these are D's. Wow, that was not what I meant to do. Let's change this thicker one too. This is my D's, these are my C's, these are my B's, and these are my A's, right? So it looks, to start out with, the same. I've got a vertical bar and I've got a horizontal bar. At the bottom, though, we're going to go in order. We'll go from smallest to largest just because we could do A's down to D's and that would be fine, but D's up to A's is fine as well. What would not be fine in this particular one is to bounce around. Like I wouldn't go A to D to C to B, right? Like I wouldn't do that. So there's sometimes a natural ordering, even if there's not a for sure way we have to start. Like if we were doing classifications, freshman, sophomore, junior, senior, you might do it in that order, freshman to senior, or you might do it in the reverse order, senior down to freshman. But you wouldn't start with sophomores and then talk about seniors and then move on to freshmen and then to juniors, right? So there needs to be some sort of an ordering going on in a way that makes sense. So there's a little space I'm going to leave here, and then I'm going to mark the next one would be my C. A little space here, the next one marked is a B. And then this little space, and the next one marked is an A. And the frequencies are the same as the frequencies we had on the example last time. So I've got 2, 3, 4, and 9. And I'm making them about equally distributed as much as I can. I'm just going to label every other one. You certainly can label every one, but I find that it starts looking a little bit too busy if I do. So I tend to like to label every other. Okay, so the D's, there's 3, so I make a bar of height 3. And then there's a space. My C's are 2, so the bar is of height 2, but you can see they don't touch, right? And then my B's are 4, so I need a bar of height 4. And then my A's are 9, so I need a bar of height 9. This looks like that. Okay, so very little difference in the last one, right? I mean, very little. The lower axis is labeled differently, and our key or our title or our label really for it is going to be letter grades. You could also say grades if you want. That would be okay, but it is letter grades. Over here on my y-axis, it's still the frequency. Sorry. I don't know what that happened for. That was fun. And then what do I still need for this graph? a title. And the title is the same that we've been working on for several of them now. This is grades on a second exam. And if you want to shade the diagram in, right, like I did on the histogram, you could do that too, color in your bars. So a double bar graph is our next one. And a double bar graph, like our back-to-back stem and leaf plot, makes comparisons in data. So it takes two data sets and it displays them at the same time in such a way that we can compare them. So we're going to use the same thing that we had done before, our back-to-back stem and leaf plot data, which was well over here. Let me find it if I can get there. Right here. And we're going to use this. So I'm going to copy this over to the other screen. And kind of make it small up here. So if you remember, the left-hand data is the first exam. The data on the right was the second exam. The tens digit is the one that's in the middle. It's the stems. The leaves are the ones digits out in either direction. The thing that works a little bit weird on this is that I don't actually have equal class widths in grades. And in fact, some people make this as a justification of why our grading scale is somehow like inappropriate. So if somebody gets a 40, it's no different than somebody getting a 59. Maybe that's not appropriate because that span of values is so big compared to somebody getting an 82 to an 85 and they all get a B. So there's some question about whether or not this grading scale kind of makes sense because the class widths are different. Nonetheless, we are looking at letter grades for this, so we are going to group things within letter grades for our discussion, okay? So when we look at the first test and we look at failing grades, that's the 40s and the 50s, right? And then if we look at the 60s, there's 1, and if we look at the 70s, there's 4, the 80s have 6, and the 90s have 4. And then we have the same thing that we've already had on the last couple of them for the right-hand side. 60s is 3, 70s is 4, 2, and so forth. So creating our stem and our double bar graph, what ends up happening is that they look much like we did in the last one, except that the categories for, and then I'll do the D's and F's, F is first, are going to be bars that do touch. So I don't think I drew that very well. Let's try that again. There's two bars that are going to touch, and they're both the F category. One of them is going to be a bar for the first exam, one of them is going to be a bar for a second exam, and then we're going to skip a little bit of space. So when I skip the space here, I'm going to have two of them side by side again, and that's my D category. And then I'm going to skip a little space, and then I have two of them side by side, and that's my C category. And then I'm going to skip a little space and have two of them side by side, and that's my B category. And I do it one more time for my A category. And it looks like a whole bunch of little hash marks down there that don't look to be evenly distributed at all. It kind of looks messy. It'll clean itself up a little bit when we start drawing some bars. My frequency will look the same as it has on the previous ones. I need to go from 0 up to 10 because that's the most I have. It's actually 9 in any of them. And I'm going to again label every other one. So we're going to do all the data from the first exam first, and I'm going to do it with a red rectangle to try to distinguish the difference. So on the first exam, how many Fs were there? No one knows. How many Fs were there on the first exam? 3. They're circled, right? There's 3 of them. So I'm going to do a rectangle of height 3. How many Ds were there on the first exam? Just 1. So it's down here on the bottom. So notice it's the first rectangle on each of the spots. So the F encompasses both of these rectangles, and I'm drawing the first one. And the D encompasses both these rectangles, and it's the first one. And I'm going to do the same thing all the way up. So for my C, how many C's are there on the first exam? There's 4. Do y'all know where I'm looking at? Because I'm not getting a lot of feedback. I'm not sure if you guys are just quiet today or if you don't know what I'm seeing. Do you know where to look when I'm asking that question? Okay. You just want to be quiet. Okay, I can get that. Okay, so we're right here, right? And there's 4 of them. All right, good deal. So there's 4 C's on the first exam. So we're right here-ish. How about B's? 6, I think so, yeah, 6 of them. So we're at something like this. And then A's, back to 4. Yeah. Okay, now for the second exam, and I'm going to change colors because I find it easier to distinguish the bars from one another if they're shaded in differently. I'll shade them later, but I'm going to draw them also differently because I can. So on the second test, how many F's were there? 0. So I don't need to do anything over there. How many D's were there? I think there's 3. Right over here, I should change colors for I'm going to be doing blue. Over here, there's 3 D's. So we're going to have 3 D's. How many C's were there? 2 C's. How many B's were there? 4, right? 4. And how many A's were there? 9. That's my tall one. Looks like this. And then I will go back and I will shade those in. And I need this to be a part of my key. So if you don't have colors with you, you can cross-hatch them. And so what I mean by that is do one of them like this and then the other one like the opposite direction, for different colors. You can do that as well if you don't have colors with you. I'm going to finish coloring mine in. And then the same thing for my red. Well, they have to be filled in some way because I'm going to need a key that distinguishes them from each other. So let me write the key so you can see what I'm referring to, okay? So in terms of a key on this one, we need to specify to the reader of this graph that this right here, this blue, means something. And if I'm doing it in red, it means something. And something different specifically. So the red grades, what are the red grades? Yeah, this is the first exam grades. And the blue is the second exam grades. So that's why they either need to be colored in or cross-hatched in some way that you can distinguish them when you're making this key. And then we need a couple more things. Somebody tell me something you noticed that's missing. A title is missing. Let's do a title. What is this going to tell us, this graph? Yeah, so this one's a comparison, right? Of exam 1 and 2 grades. Some version of that would work. What else is missing? Labels. I need a label on the bottom and on the side. Let's start with the bottom. What's the label on the bottom? Yeah, letter grades. You got it. Just like the last one, right? So down here, it's letter grades. And what about the side? Frequency. Okay, is that all right? All right, now you're going to use your protractor. So let's talk about what that graph looks like. All right, our last graph that we're going to do is a circle graph or pie chart. And so it consists of a circular region partitioned into disjoint segments. This graph shows how parts are related to the whole. Now, sometimes parts related to a whole is something we care about, right? You've done part-to-part comparisons in this class. We've done it with ratios. We've done it with odds, right? Sometimes comparing, those kinds of pieces part to part makes sense. Sometimes it doesn't. Sometimes it makes more sense to do it like this is describing, part to whole, right? Everything we've done so far, especially those bar graphs and so forth, are comparing part to parts. But if we're looking at this as we're comparing part to whole, we're trying to figure out how much something is of the whole, people, surveyed or whatever the description is. So here's our example. It's the same one we've done before, the grouped frequency table with the second exam data, okay? And we're going to create a circle graph. So let me get my data from over here. I think it's here, yeah. And we're going to move it over there again one more time. Okay, so in order to make this make sense now, I'm just going to expand this. You can jot this down again if you would like. In fact, I would encourage you to do so. You can leave off the tally column. That doesn't matter. You can leave off the 60 to 69. So what parts of this we're going to need are the letter grades and the frequency, okay? So jot that down on this side of the paper. And what I'd like for you to do first is figure out how many people took this test. What'd you get? 18. 18 people took the test. If you'll remember, this was actually one of these classes. 18. Our cap is always at 20. So 18 was a fairly full class for that particular semester. 18. And what we want to figure out is what percentage, what proportion, what ratio, whatever word you'd like to use, each of those values is out of 18. So what we're going to do is we're going to take each of these values out of 18 and figure out the percentage for it. So I don't really want, I want the percentage as a decimal and as a percent. So we're going to actually write it both ways because it's going to be more helpful in one place than the other in both of those fashions. So if I take 3 over 18 and I divide, what do I get for a decimal? I don't have this one written down, so somebody's got to tell me the decimal for this. It's point something. Promise you. 1/6, is it 6 repeating?
Yeah, there's a 7 at the end.
Yeah, because your calculator stops doing it. So this is 1/6 repeating. If you turned this into a percent, rounded to a whole number, you would get 17%. Does that make sense for everybody? Because we're always going to round our percentages to whole value percentages. At least the questions that I ask will. If your book does it differently, feel free to choose. Not feel free to choose. Please do what they've asked. But percentages for me, I'm going to do whole numbers. Let's do 2 out of 18. So what happens when you divide 2 out of 18? Ooh, we get 0.1 repeating. Excellent. And if you multiply that by 100, round it to the nearest percent, you'll have 11%. Is that okay? All right, let's try 4. What do you get when you do 4 out of 18? 0.2 repeating. If you multiply that by 100, round it to the nearest percent, you get 22%. And how about 9 over 18? That's 0.5. What is 0.5 if you multiply by 100%? 50%. Okay, are we good so far? Okay, now that's not all we need. We need one more piece of information. In order to have space for that, I'm actually going to delete my tally column so that I can shift it over. I mentioned that we weren't going to need it, so let's actually just delete it out so I have a little bit more space here. So the last column that I need, and I will make these kind of separate columns here, is I want a column that represents the amount that we have of the circle. So thinking about geometry, I know some of you have already had geometry even here at OBU. If you haven't had it here at OBU, you had it in high school. Do you remember how many degrees is in a circle? 360 is correct. There's 360 degrees in a circle. And what we would like to do is we would like to find the degrees that are represented by each of these fractional segments instead. So if you take your calculator back out and take 0.16 with the 6 repeating, feel free to type in a bunch of 6s, that's just fine. What I'd like for you to do is to take that and to multiply it by 360 so that we can find the percentage that we have out of, not percentage, but the degrees that we have out of 360. What did that give you? Okay, 59.9 repeating, which would be what?
60.
It's 60. This is 60 degrees, and that's correct. What happens if you do your 0.1 repeating times 360? We're going to do a whole number of degrees. If we do need to round, it's going to be a whole number. Excuse me. What's this one? 0.11111. What is it?
40.
40. Yeah, it is 40. What happens if we do the 0.2 repeating for my 360? It's 80. Good. And then the last one is the 0.5. What's half of 360? I hope you know that one. Yeah, it's 180. Okay, good. Okay, is everybody good with that? Okay, so this column in the middle is my percentage column, and this column over here is my degree column. Now, I want you to find those quantities. Does it need to be quite as structured and organized as I have it? No, not really, but it's probably helpful to have a little bit of that structure and organization in so that you don't lose track of values and so forth. But we're using all of those things to create a circle graph. So this is going to be my circle graph. If you don't draw circles very well, which is probably most of you, grab a water bottle that's with you and trace the bottom of the water bottle. It's fantastic. If you don't have one, I bet your neighbor does. Taryn's might be too big for her paper. I'm not sure. She's going to give it a go. Okay, so grab a water bottle that you have or that somebody nearby you has and trace the bottom of the water bottle. Do we not have that many water bottles in class? Okay, y'all are just staring at me front row. Chesney, come here. Take my water bottle. It's not a perfect circle. It's been banged up a bit, but it'll be okay. Okay. So I need you guys to create a circle. I'm going to do a circle on my screen, but I have the advantage of a technology circle. That's not fair at all. I know. Okay? Yep, just pass it over. Just pass the water bottles around. It's all good. Whoever needs one, Avery doesn't need one. She's got technology too. Jamora, do you need something to trace around? Nope, you're good. Okay, you're gonna eyeball the center of the circle. Okay, so just put a dot in the center of your circle. Even I'm gonna eyeball the center of my circle. I don't have a way in this particular app to give me an exact center, but it's close enough. And you're going to draw a segment out from the center, and it doesn't matter where it goes. I'm just gonna draw mine to the right. Feel free to draw yours wherever you'd like. Now, it's going to be the easiest on this one for us to use the 180 first, because 180 is how much of a circle? It's half, right? It's a semicircle. And so we can cut this in half really easily, wherever we made our center like that, and go the other side. And this piece, that's either the top or the bottom, whichever you pick, I'm going to use the top, would be 50%. And it's representing the section that was letter grades of A. So within the circle sections, they're called sectors, you need to at least label the category, that's A, and the percentage. If you want to write the degree measure in there, you certainly can, but you don't have to because you used the degree measure to make the size already. Make sense? Okay, the bottom half of this circle now needs to represent the other three letter grades. Thank you, ma'am. So B, C, and D. And we need to go in order. Well, after an A is a B. Don't go AC. That's not going to work. We need to go in order. So A and then B. So how many B's were there, percentage-wise or degrees? Degrees-wise? 80 degrees. Okay. So we are going to attempt, I'm going to sort of sketch it in here, and then I'm going to show you how you find an actual graph using your protractor. Okay, so you're going to need your protractor. It's going to look something like this, right, from my screen. Okay, I'm going to put my B down here somewhere. But let's actually find where that mark is supposed to actually go. So let's talk about how we use a protractor to make sure that you remember, or if you haven't used one ever, maybe to see. So every protractor has kind of a level on the bottom. It's not the bottom of the protractor, but there's a straight line on the bottom. Do you see the straight line on the bottom of yours? Okay. And there's a circle in the middle often that looks almost like a magnifying dot. Do you see that? Okay, that dot in the middle needs to go in the middle of your circle. And one of the lines, right, the edges, that's the flat edge, needs to go along the edge that we're measuring. So it's going to look like this. The dot in the center goes here, and then the line line is going to measure right here, around here. So it looks something like this. Is everybody good? Okay. Along the outside edges of the protractor are two sets of numbers. One is an increasing set and one is a decreasing set. Okay? So if you're measuring up, which is what we normally do, we want to make sure we're measuring the increasing set. So if I'm measuring, and it's increasing from one direction and decreasing from the other direction. So on this one, the way I have it set up when I put mine on there, I'm going to be measuring from the center 0, like the 0 that's on the middle. So when I line this up, like so, I want the 0 right here to trace around here until I get to 80. So I'm going to attempt to not touch too much of my screen, but to do it anyway. That's what happened. And if I measure out to 80, it looks like it's about right here. And then you're actually going to connect with a line segment, the center of your circle, to that little mark that you made. If it goes outside your little circle a little bit, that's okay. You can erase it, make it look a little cleaner. But that gives us the mark that's going to be the approximate angle for B. And then B was what percentage? 22%? Yeah, so it was 80 degrees, 22%. The percentage has to be there. The degrees can be there. After B, what do we have? C. So my C sector needs to touch my B sector, not my A sector. Got to go in order. And instead of lining this up with the dot in the middle and the line where it was before, the dot stays in the middle, but the line will now be along the line we just drew for B. So it'll line up like this. Okay? So that line is lining up along the new line that we just created, that flat balancing line. And you're going to go out to what angle measure this one, on this one? 40 degrees. Okay, so you're going to take this, you're going to do the same thing. Mine looks like it's about right there. And you're going to connect them with a line segment, like so. And this will be C, and it said it's 11%, correct? Now, the only thing left is D's because this test didn't have any F's. So the last sector is the D sector. And what was it supposed to be percentage-wise? 17%. What was its angle measure? 660. Okay, so it's not a bad idea to verify that it actually worked, because otherwise you might have made an error somewhere else. So again, you can line your dot up in the middle, the center of the circle, and line your line up along the line you just drew for the line that marked out C. And you should be hitting back at the horizontal, at least that's the way I drew mine, the original line we drew for A, at about 60%. Okay, so if I ask a question like this on a test or a homework question's graded or whatever, we're going to use a protractor to make sure you're close. Does it have to be perfect? No, it doesn't have to be perfect, but it shouldn't be super far off either. Okay, if it's super far off, it means either you're not using the protractor or you're not really understanding how to use the protractor. You want to get that issue addressed. Okay, does that make sense? Idea how to use a protractor. Excellent.